So let's get started again. Welcome to the first Intelligent Project webinar. Thank you all for joining us. My name is Jasna Komatovic and I'm yours today's host. At the end of all sessions, we set a dedicated Q&A session, but during the webinar, feel free to post your questions, suggestions, if you have some comments or thoughts in the group chat, or if you prefer so, you can send me a direct message. So today's webinar is divided into 5 sessions that will be covered thematically by our lecturers or presenters on the topic listening before building, what communities need from peer-to-peer energy trading by Laura Perez from R2M Solution Spain. Laura is also Intelligent Project Coordinator, followed by Paulo Lisa from University of Galway, Ireland, Quentin Denet from Smart Energy Europe, Belgium, and Lisa Diamond from Austrian Institute of Technology. So it is my pleasure to introduce our first speaker for today's session. Please join me in welcoming Laura Perez from R2M. She will deliver the opening remarks. Laura, the floor is yours.
Thank you, Jasna. Good afternoon, everyone, and welcome to the first webinar of the Intelligent Project. On behalf of the whole consortium, I would like to thank you all for joining and for your interest in our project on the work we are developing. Intelligent aims to contribute to a more citizen-centric, flexible and resilient European energy system by developing open and interoperable solutions for peer-to-peer energy trading and local flexibility sharing. However, technology alone is not enough. The energy transition is also about people, the citizens, communities, and all the stakeholders who will use these solutions and participate in new energy models. So this is why with this webinar, before developing new tools and platforms, we wanted to show you how with the project and the work we've been developing in the first half of the project, they aim to understand the needs, the expectations, the motivations and challenges of real energy communities. We wanted to know what would make peer-to-peer energy trading and flexibility services more valuable, accessible and meaningful for the people who will ultimately use them. So this is the role of the work package 2, which is now successfully completed. The work carried out during this first part of the project has provided us with the social but also the technical requirements that will guide the next stages of the project. So all the insights collected from our pilot communities are now becoming the foundation for the development of intelligent technical solutions, including the interoperability infrastructure, the optimization services, peer-to-peer trading platform, and all the demonstration that will follow after. So this webinar is an important milestone for us. It's the opportunity to share what we have learned so far, but also to show how a user-centered approach can shape the innovation in practice. So without taking more time from our technical partners that are speaking after me, I would like to thank all the partners involved in the project and especially the colleagues that are going to be presenting the results today. I hope you enjoy the session and it will generate an interesting discussion. Thank you.
Thank you, Laura. Thank you so much for those insightful opening remarks. So please join me in welcoming Paulo Lisa, who will open the second session of today's webinar, named Setting the Scene, Why We Listen Before We Build. Paulo, we look forward to your presentation. Feel free to share the screen.
All right. Thank you very much. Okay. Yes. Can you see my screen now?
Yes, but it's not in a full mode.
Yeah. No, police. Right. Okay. Just move a few bars in here. Okay. 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 Hello again. My name is Paulo Lissa from the University of Galway.
Sorry, we cannot see it. It's the full mode. It's the full screen mode, but it's empty. It's only in white color.
All right. It's supposed to be that way.
Yeah.
Right. Can you see my screen now?
Yes, it's perfect
All
now.
right. Thank you very much.
Thank
Sorry
you.
about that.
Just go ahead. The floor is yours.
Yeah, so let me just start again. So my name is Paulo Lissa, and I will start with an overview of the work package 2, which is about the social and technical requirements analysis of peer-to-peer energy marketplaces. In a nutshell, this work package provides a background and context to support the development and demonstration of the user-centric intelligent solutions, considering the social, technical, and regulatory aspects. We have 5 deliverables in this work package, and we have the technical part in work package in deliverables 2.1 and 2.4. The 2.1 is about the data collection and data-driven analysis, and 0.4 goes a little bit beyond and sets the product requirements, solution design, and KPIs. Then we have deliverable 2.2 with the regulatory analysis of peer-to-peer energy trading models that my colleague Quentin is going to present in a couple of minutes. And then we have the social aspects in deliverables 2.3 and 2.5, which are about the stakeholder and context requirements and the user-centered interface design report. I'll be talking about 2.1 and 2.4. So let's get started. But before I proceed, I just want to introduce the pilots that we have in Intelligent. We have 4 pilots. 2 of them are located in Switzerland. I want to show you like how different they are. So this is very important for the project because we want to check like different settings and see how the solution will be scaled like to other like places and communities. So the first pilot is the Lugaja Innovation Community, in which we have 18 single-family homes, kindergarten, PV, and storage that are just one for the whole pilot. And we have some like heat pumps and electric boilers in this pilot. In the second pilot, we have a different setting. We have three residential buildings with 23 apartments. It's called Collaborative Energy Living Lab. And in this pilot, we have 3 PV systems and also a hydroelectric plant and storage and EV charger. So a bit different from the first one. Then we have the third pilot, which is located in the Aran Islands here in Ireland. This pilot is very different compared to the others because we have a number of scattered houses and buildings in the island. So we have 16 residential buildings, 2 commercial, 4 public. In this pilot, the PV installations and storage, they are located in each of the buildings. So we don't have just 1 or 2 or 3 PVs for the whole like pilot. So this is a different setting. And the fourth pilot is in Portugal, Greenvolt Comunidades, and in which we have 2 urban energy communities with a PV installation of more than 900 kilowatt peak combined, and storage, EV charger, and heat pumps and electric boilers. This is just to show you like how different they are and how we tackle all the data collection and getting the context from each of these pilots. And this started in deliverable 2.1, which is the local energy community data collection and data-driven analysis, in which we created a framework which started with the identification of the required information like from the pilots, we developed data collection templates that was shared with the project partners, like the technical partners and the pilots, so they could check if we had everything that they needed, like for their deployments. Then this was shared with the pilots, and we had this validation, and they started to be completed in those spreadsheets. And at some point, we started collaborating, providing outputs to other tasks, such as 2.4 that I presented in a minute, and other parts of the project, intelligent in general. And last but not least, we had the validation of this information. And this, with all this framework, we created deliverable point 2.1, which gives information to important outputs for the technical work package 3, 4, and 5, and also for the validation of the projects in work package 6. So in task 2.1 and deliverable 2.1, we started getting information at a high level view, like get information about the countries and like in relation to like the regulation and to the climate and everything. And then we started to look into a building level. So the number of the buildings in each of the pilots, if they are like residential or commercial or public. And after we did this assessment, we started to look into more details in the energy assets available. So we tried to identify the storage systems, the renewable generation in each of these buildings. And then we went like even further and we understood what were the available data that we were collecting from the pilots, like energy consumption measurements and energy production and so on. And with this in mind, we created those spreadsheets that were used to collect this data. And with these spreadsheets, we were able to get some insights and create the topology and understand the potential of each of the pilots. And finally, this also helped us to understand the type of energy management systems and the available data analytics that we had, like from previous project and also like from the manufacturer portals. So we could estimate the potential of energy flexibility in some of the buildings participants in this project. We have this like for each of the pilots, and this is a live document in which the other partners can keep updating if another building is part of the project in the future. Then we have deliverable 2.4, which is the project requirement solution design and KPIs. This extended the initial work in 2.1 and defined the technical and functional requirements for design, deployment, and operation of the intelligent platform. So in this deliverable started by describing the core technical solutions. In this project, we have a consortium with different technical partners, and each of them had like their own work. And so in this work pack, in this deliverable 2.4, we understood like what were their capabilities and what they would be providing like for the pilot, for the project as in general. And then building upon 2.1, we had the pilot readiness assessment. So after identifying what is the solutions that we would be developing in intelligence, we tried to match it with the assets and buildings that we have in each of the pilots. And after that, of course, it was very important to understand and create the interoperable system architecture, because we know we have like different services running, different pilots receiving information from different sources. So it was very important at this stage to create this system architecture that could take all of this into account. And finally, in this deliverable, the key performance indicators were created, so we could assess. So we will be able to assess all the platform and the project objectives in the end of the project. Just a bit about the core technical solutions that I mentioned before. 3 or more detailed in this deliverable 2.4. The first one is the Grid Singularity DEX, which is the open source blockchain-based platform in secure automated grid-aware peer-to-peer energy and flexibility trading. We have FOSS, which is the artificial intelligence and machine learning-based optimization system. So everything that is about energy forecasting, optimization, and other mechanisms, this is part of FOSS. And we have also the Energy Web digital spine, which is the decentralized data extending infrastructure. Moving to the pilot site readiness assessment. Again, after we collected the initial information in deliverable 2.1, we did an assessment in the pilots considering their current conditions, technical readiness, and available data infrastructure. And with this, we also, this was a very important step because we were able to match what we had in pilots and with the services that we want to provide and the technology to be deployed. So the pilots we could see what was missing and provide suggestion and act in things that we need to change it and to enhance in the pilot so everything can be deployed. And finally, we have the key performance indicators created. We have 5 main categories. We start with energy efficiency, which our target is to have a greater than 5% improvement. We have economic also with greater than 5%, environmental, that will evaluate the self-sufficiency and self-consumption rates. User engagement, this is very important, and my colleagues will be talking about this later on. And finally, we have the technical feasibility KPIs, which aims to validate and check the readiness and the development of our solutions to see from where we started and how we progressed over the project. That's it from my side.
Thank you, Paulo.
Thank you
very much. Thank you for the presentation. A lot of data, I might say. The next presentation is from Quentin Dernet from Smart Energy, but I will share his presentation in his behalf. Quentin, are you here? I hope that you can. Yes, okay.
I'm here. Good afternoon, everyone. Yes, I will start with the presentation. My name is Quentin Dernet. I'm working at Smart Energy Europe. We are the European Business Association of the Flexible Demand Management Industry, which means, in short, we are the European voice of demand response in Brussels. So today I would speak about a topic that I'm sure will thrill the audience, regulation. Can we go to the next slide, please?
Okay.
Yes, so within this project, we drafted a report. You have the name right here. And what we did, we assessed the regulatory readiness of the different pilot sites. Not only we did this, we provided also an overview of what is the European legislation covering the topic of this project. We also see what could be understood as the best practices implemented at European level. And finally, we did a stakeholders assessment. We approached TSO, DSO, suppliers, aggregators to actually know what is their view on energy sharing and the potential impact on their business model. So one of the things that came out from this study is this regulatory requirements. Here you can see there is different steps. The step that we need to fulfill in order to have a full implementation of the intelligent solution on the pilot site. So they are 4. Can we go to the next slide, please?
Yes, sorry.
The first one is The first one is quite basic. Is it possible to do individual self-consumption? So are the consumer able to self-consume electricity that is generated? So for example, if they have some PV channel, can they consume this electricity? Most of the time, the answer is yes. Now it's really the standard approach across the EU. Can we go to the next slide? So the next step, is it possible to create a collective structure? So in European regulation, the end user are able to create this collective structure. So it could be renewable energy communities, citizen energy communities, or a collective self-consumption teams. This is quite common now, not possible everywhere, but in most of the country. But for our solution, there is something that we need more. It's an extended proximity criterion. The proximity criterion is set the geographical limit in which we can create an energy community. It's really important for us. Okay, you go back to the
sorry.
No problem. There are some countries where energy community are just set on a single building. That's mostly the case in the Nordic countries. For our solution, what we need, there is a greater benefit when we have different consumer profile. So some people that will generate more electricity and some people that will actually consume it. So for our solution, it's better to have an extended proximity criterion, let's say over a few kilometers. Can you go to the next slide, please? Yeah, the third step is to enable energy sharing. So here, what you can see, energy sharing, it allows to distribute the electricity generated by the community-owned asset, which can be also participant-owned, to the different members of the energy community. On the left, you have what was the former energy community model, or let's say energy cooperative. People within the community were jointly purchasing a generation asset. All the electricity was sold to a supplier, and the revenue generated was either passed on to the participant or used to create a community project. Energy sharing completely changed this picture. Now, first of all, the electricity generated will be distributed to the participant. Only the one that will not be consumed will be afterward sold to an electricity supplier. And these are several benefits. It increased what we call the self-consumption of energy. It helped to reduce electricity bill. It helped the local resident, it improved the community resilience by actually reducing the reliance on imported electricity from the wider grid and reduce the strains on the distribution network. Can we go to the next step? So here I said it's one step, actually it's 4 little steps. How to create an inner community peer-to-peer market. So here we saw that there is 4 requirements needed to have a full implementation of our solution. Price differentiation, recognition of dynamic sharing coefficient, possibility to share the coefficient ex post, and alignment in the bidding and the communicating this coefficient. I will explain a bit more in detail. Can you go to the next slide, please? First, we go on the price differentiation. So energy sharing, it's actually based on the compensation paid by the consuming participant for the electricity he consumed. Within our solution, we do the allocation of electricity according to an auction-based mechanism. Therefore, we need a price differentiation. There is in many countries, the price of sharing, the compensation of the shared energy is settled by the government. So you cannot have an auction process. To have an auction process, the different participants need to set their price preferences. Could be from the generator or from the consumer. So this is needed in order to have the allocation of energy where it's the most valued. Of course, there can be some boundaries. I put them here. So for example, on the maximum price, that will be naturally the consumer electricity price that you have with this retailer. And the minimum would be the generator feed-in tariff. Oh, I think that we are going quite far. And go, yeah, we're almost there.
No, sorry.
Yeah, well, I can speak, no problem. Before. Okay, and for the generator, so it's feed-in tariff. That's not mandatory in all the projects because there can be some communities where the electricity generated by the community-owned asset is given at discounted price to energy vulnerable households, for example. So that's not always the case. So first, price differentiation. Then the sharing coefficient. Can you go to the next slide, please? So the sharing coefficient is the methodology that will be used in order to allocate this energy. The sharing coefficient is given to the DSO, and this DSO will do the settlement acting as a third neutral party and using the smart meter data. What you have here is the methodologies that are mostly present at European level. The first one is fixed, so that's quite straightforward. What you have with the fixed sharing coefficient, each participant received a percentage of the asset generation. You can see A will receive 40% of the generation all year long. So this one for us is not really efficient because the electricity can be allocated even though there is no consumption. So not optimal. The second one that is quite common is the proportional coefficient. So here the electricity is allocated according to each participant's share of the total consumption during a given period, let's say 1 hour. So here it helps to increase the rate of self-consumption, but on the other hand, it might favor the entities that have the highest consumption. So here, participant A consumes 60% compared to the overall energy community, so it will have 60% of the generation. What we need within Intelligent is a dynamic sharing coefficient. Can you go to the next slide, please? So the dynamic sharing coefficient, it allows the community manager to change the allocation of energy for every time step. So like this, we can actually reflect what is the outcome of the auction process made by the platform that my colleague spoke a bit earlier. So this allows to give a significant share of flexibility in the solution and to increase the overall self-consumption rate. Can we go to the next slide? So the next one is when actually we give this coefficient to the DSO. I mentioned it's the DSO that is doing the settlement. And we can send this coefficient into what we call ex ante, so before delivery, or ex post, after delivery. And for intelligent solution, what we need is to have an ex post allocation. Let's say ex ante 1 day before delivery. Why? Because it allows us to have actually an auction process that is quite close to the real time. With this, we have more accurate generation forecast based on the updated weather data. We also have an improved consumption forecast. It's difficult for consumers saying what you will be consuming in 1 year, for example. And it enhances the control and verification of the exchange. So we ensure that actually what have been the exchange that was settled in the platform really occurred physically. And that's linked to my last point. Can you go to the next slide, please? Here is the link between the billing and the sharing coefficient. So here we have some countries. I would take the example of Spain, where you can update the sharing coefficient only 4 times per year. And that's a significant, so to say, not a barrier, but it leads to having really conservative auctions process. What we need is actually to have certain coherence in between when there is the billing cycle and when we share this coefficient. We'll take the example of one of the pilot countries, Portugal. So here for a billing, let's say the billing cycle of February, you can communicate the sharing coefficient in early March. And why is it important? Because it allows actually our solution to improve the control and verifications. We have within the platform some estimation of what would be the end user saving. If what we mention in the platform is not what the consumer will actually see on his bill, it's possible that the end user will actually lose a bit of trust on the platform, and that can actually decrease the participation. So that's why this point is important to us. I think I'm almost over with this presentation. I just have one last slide where actually we see what is the regulatory readiness of the different pilot sites. Now Switzerland is all green. That was not the case when we actually did the first assessment. The regulation changed a bit more than a year ago. Switzerland is a particular case because it's not touched by the European regulations. For Ireland, actually, it's not possible to do energy sharing. All the electricity generated within the community needs to be sold to an electricity supplier. So that's a real blockade that we have within our solution. This might change in the future. We have been in contact with the regulator, but we are not sure when. And finally, we have Portugal. Portugal is, in our perspective, currently the most comprehensive framework for energy sharing that is present in the EU. Not perfect, but one of the most comprehensive. And in our perspective, all the different criterion will actually enable the implementation of intelligent solution. I hope I was clear enough. If you have like any question, I put my mail on the beginning of the presentation, so do not hesitate to send a mail. Thank you very much.
Okay, Quentin, thank you very much. One second, I think that there is let's say, time to invite Lisa Diamond from Austrian Institute of Technology. Hi, Lisa. Good afternoon. Lisa will outline the session and open the next two. Lisa, since that the next sessions and the presentations are yours, feel free to give yourself time to set up and share your presentations. You can start when you are ready, okay?
I'm happy to share, as mentioned. So, just a second. We'll go with this. Now we have the split. Just a moment. I thought I integrated this. No, it's okay. It's fine. This is the right one.
We
okay.
can see, but it's now it's perfect.
Yes. Yeah. I know it was. I was just searching because I had them originally separated as presentation because I had assumed that Paulo would talk in between again, but now I can put them. I put them together.
Okay.
Yes. Thank you very much for passing the floor to me. My name is Lisa Diamond from the Austrian Institute of Technology. We are in Austria, and we're working on developing and evaluating future technologies that support positive societal change. And me and my colleague, I and my colleague Marcus work at the Center for Technology Experience, where we're looking specifically at how to turn human needs and requirements how to shape technologies in a way that they meet human needs and requirements best. So we work quite broadly at different types of technologies, and I focus very much on developments in the energy sector. And I will be presenting the user research work that we did, and my colleague Marcus will afterwards continue towards the designs that were developed based on our results. We worked with stakeholders to gain a broader understanding in our requirement analysis, and then moved on. So this was the beginning, and then moved on to user groups. So I will begin with these results here. We carried out 4 stakeholder workshops that were actually the stakeholders involved. So we started with a stakeholder mapping that was part of a number of initial interviews that we did with the community managers to understand which stakeholder groups were critical and which ones were present and important at their pilot sites. And based on this, the community managers invited stakeholders to participate in 4 workshops that we carried out online. The represented stakeholder groups, the stakeholders varied from pilot site to pilot site, depending on the identified core stakeholders, but also possibilities and contacts of the community managers who took over the recruiting in this context. But we had both local and governmental authorities represented. We had regulatory body. In one workshop, DSOs were present in multiple workshops, where technology providers, sort of community representative groups, and obviously academic institutions and community managers, since we also had people directly from the project involved in them. Within these workshops, we specifically looked at enablers and barriers of peer-to-peer trading communities, and also impacts of both success, if peer-to-peers established successfully, but also failure on both the community members, but also the participating stakeholders. And building on the failure or looking at the failure risks, also specifically at mitigation measures, or what is important for mitigation. And so this will be presented as well. So in terms of enablers for from the implementation perspective, or directly connecting with the work that Quentin presented previously, supportive regulatory and legislative framework is critical to be able to implement successful peer-to-peer trading. You obviously need the technical and digital infrastructure, the data availability and quality is critical. That is something that I think in the early phases, there's a lot of struggling still with this aspect. Interoperability, also not surprisingly, from all the different technologies and solutions involved, and also critical is a strong stakeholder perspective, cooperation between all the parties that play a crucial role, so that there's really awareness of what's happening and that everyone is working towards the same goals. And from a participant perspective, awareness is important, obviously, so people need to know that this possibility is here. A certain amount of literacy is important to help understand both what is supposed to happen within the community and their role in it. There needs to be sufficient economic value. That is also a tricky aspect, especially if you're looking at sort of inclusivity components, where the larger your loads are, the more sort of complex technology can afford, the easier it is to gain benefits from this type of work, while the more limited you are in terms of if you have already a small footprint and you can't implement automated solutions, that makes the participation more difficult. So that is an important aspect as well, how to create economic value for different types of user groups. Then the automated solutions, that optimization can be implemented manually, but it's labor intensive and time intensive. So involving automated solutions is preferable from user perspective. Does require the connected transparency and control, though, which will emerge repeatedly in the further results that we'll be talking about, and the user friendliness of the technology that they're connecting with. In terms of risks and barriers, we see a lot of mirroring of the enablers, so the regulatory uncertainty and constraints, weak economic incentives, lack of infrastructure, and so on. But additional ones that were present were specifically the participatory and operational complexity as challenges. Then transparency issues, as I mentioned before, the people not understanding sufficiently what is happening in their home, in their community, what the actual impacts are, and what if their personal sort of benefits match with what they're providing, and also privacy and security concerns. Looking at sort of what success means and looks like of peer-to-peer trading from the stakeholder perspective, so on the user and societal framing, we see, they would expect to see demonstrable financial benefits, community empowerment, the emergence of energy citizenship, in general, local benefits, which can also mean a reduction of energy poverty, tying a bit to what I mentioned before with the benefits for different kinds of user groups with different kind of equipment and setups. Then obviously there's the increase of renewables and self-consumption, and on the stakeholder side, positive return of investment, competitive pricing, efficient integration of grid operation and reduced grid stress. That's obviously a very important point for DSOs as well. The overall and emerging of new roles and service opportunities, and tying again back to the regulatory aspects and further improvement of regulatory conditions, supported by the success that also improve scaling, and an increase in trust and legitimacy. The failure sort of visions mirror a lot of this again, like as previously, specifically talking about risk mitigation possibilities. there was pilot projects. So very much what we're doing right now that enable iterative learning and supports that large-scale implementations in its position where the early sort of issues have already been identified and solutions have been found, so they start from a good point. Having early and continuous user involvement, transparency in communication business models, overall simplification of participation processes and also interfaces, and then general tying back to the enabling factors, awareness raising, education, capacity building, and fostering of strong partnerships. And that sort of wraps up the stakeholder results. And since we already completed the rest of the sort of laying the framework laying, I can now move on directly into the work we did with users. The goal here was to understand user requirements, both on a sort of more conceptual general level, so main objectives and concerns, but then also in a more concrete manner, information on what they would expect from a platform, how they would want to use it, what information and interaction opportunities they would want to have to inform our conceptual design activities that followed this work. We worked with two user groups that emerged from the early discussions in the project, where there was a need for user interfaces on one side, community members or prospective members, and on the other side, community managers. We started with quantitative work with a sort of more general requirement survey that explored motivations and concerns also overall regarding energy community participation, more specifically expectations towards peer-to-peer trading, and then preferences regarding UI elements, both regarding information and interaction, channel preferences, and also regarding demand-side management, automated demand-side management, conditions for allowing this. This was an open question, this last point. And then building on the quantitative results, no, it's fine. I'll explain this afterwards. Building on the quantitative results, we carried out qualitative work. We had 3 workshops with community members, and one that also specifically included community member representatives, where we tried to understand in a bit more detail how people imagined impact in their lives of peer-to-peer trading, what they would expect there. Of such a community membership, and also looked in more depth at UI expectations, and also just in a more open manner, because the survey included a lot of closed questions, and we wanted to open this up a little bit in the member discussions. And then finally, this qualitative work concluded with a workshop with the managers that built on the previous contextual interviews that we had carried out. Looking a bit more closely at their sort of their role within the community and the activities that they needed, the platform functions that they would need to carry out this role, and again more specifically information and interaction aspect. Looking at the survey results regarding the motivations. And now we come back to this point that I forgot before. We actually carried out 2 surveys. One was with the pilot participants directly, but we also carried out a larger panel survey throughout the participating countries to have more robust findings. And also it was actually quite interesting to see there was a lot of overlap, but some things were different that were quite consistently different. And so that's why I actually mapped these here with each other, because I think it tells something as well. So what we saw was both for the community members and the panel participants, that financial benefits, environmental benefits, and increased energy autonomy were the core sort of motivations for participating in energy communities. We saw that the panel actually cared a little more about grid stability and learning motivation, and this aspect already sort of shows and underlines what we saw relatively continuously, that the pilot members had a bit of a more pragmatic approach that highlighted stronger actual interaction aspects, not surprisingly, while the panel in some points was a bit more idealistic and also showed a stronger need still for information and learning. Again, not surprisingly, because they're lacking most of them lacked at this point actual direct experience with energy community participation, and not all of them had energy assets in their homes. So yeah, it was a different sort of starting point for them. The barriers I haven't included in the survey, but they focused on for both of them regarded about sort of complexity, technological and organizational complexity of the whole thing. A little bit transparency issues, and again with the panel you saw also sort of issues with cost concerns, which was less of a point with the pilots that had already have the technology, the required technology to participate. In terms of peer-to-peer expectations, we saw for both survey groups that direct personal benefits was most important to them, building on the motivations that we had that were discussed previously, and transparent pricing and trading info. Here again, we see this a bit more sort of idealistic perspective from the panel that also asked for fair benefit distribution in a more highlighted manner, which wasn't quite as important for the pilot participants. Continuing more specifically to the user interface aspects, it was most important to see the savings and earnings, directly connecting again to the core motivation of the financial benefits and the personal benefits, but also just having overall transparency regarding consumption and production. The panel also wanted sort of proof that the traded information was energy was green. That was a bit more emphasized in the results from their perspective. And looking at the interaction preferences, the setting of trading priorities was important to the pilots specifically, the defining of trading prices, and also wanted to be able to set demand side management related alerts. That was included since this was quite an early stage of the project, and we also wanted to have the questionnaire be a little bit more open, but demand side management is actually outside of the scope of intelligence. So this part wasn't addressed further through the interface designs. And this is a sort of last look at this open question, at the open question results regarding the acceptance of external automations, optimization, external optimization conditions. Financial value again was the one that was mentioned most often. So people want to see that it's worth it for them. They want transparency, so being able to see what's actually happening, what is done, what's being done, why is it being done. They want control options in terms of like setting, sort of shaping what is in general possible and what's not, but also being able to interrupt if they're not, if there's a problem with an implemented automation, and overall reliability, which also includes comfort aspects, so that that the automation respects their needs, and they can know what to expect from it, that it isn't doing things that they can't follow and they can't know what will happen. And with that, I will move on to the workshop results, where we see a lot of the things sort of repeated. We saw that the clear value is what actually drives the interest. So we have, again, the cost reduction, the autonomy, self-sufficiency, and sustainability as core motivators. We did see sort of local characteristics coming through and connected with the context that the communities are in. So for Ireland, the Irish community on an island, resilience and independence was particularly important, which connects with the aspect that as an island they struggle more with energy provision blackouts. So being more independent from the general grid would be of particular value for them. The Portuguese pilot at the time included a social housing group, actually. So this sort of inclusivity and involving different types of users was something that emerged a bit more strongly there. Then again, we have this transparency point, that having transparency is the thing that builds trust, especially if you're talking about automated processes. There was a need for visualization of the production consumption data, seeing in general the energy sources and flows of energy, providing transparency of trades that are implemented, and overall cost transparency. And on the main bearer side, they were a little bit sort of broader. We actually saw regulatory uncertainty mentioned. We saw infrastructure costs mentioned. Fairness concerns were present in specifically the Irish workshop, it was, I believe. And the long-term viability was also mentioned, because that's one of the challenges if you're working in these pilot projects. Often things are set up, the technology is set up, they're provided with insight possibilities and so on, and then the project ends, and it's a bit in the open air how often benefits gained during the project times is lost, and there's no money anymore to support things. So this is, and they have been part of multiple projects already, and I think that's why this concern was mentioned specifically. Looking more at the UI aspects, being able to have control was emphasized again. So overall, the intelligent optimization was welcomed. There's many users that don't like. We did see sort of the sort of expert user groups that were very interested in lots of details and being able to see everything and being able to take more detailed control. But there were also a lot of people who very much didn't actually want to do a whole lot and weren't interested in the large details. But they did want to, in general, be able to take control if needed. So having this option, being able to configure your preferences, so to know that the optimization works along what is important to you, and having this possibility to override was deemed important. They wanted value and pricing made transparent, so showing savings and earnings, having transparent pricing structures and clear cost comparisons between the peer-to-peer prices and the grid prices. And regarding the interface overall, clear information hierarchy was important. Being able to having easy navigation, in general limited notification, and onboarding support, also like in person by people, not just AI, was also something that was mentioned. And finally, concluding the requirement insights, the manager workshop that we carried out highlighted the need to be able to review KPIs through the manager UIs, to be able to monitor the system overall and see if there are faults. So if an asset doesn't send data anymore or stops responding to automation, there was a need to have very prompt information about this. The visualization of consumption and production in general, but also the forecasted and the expected optimization. The possibility to track the peer-to-peer trading within the community, to handle billing through the interface directly and prompt payments in case of late payments or so on was also there. Then in general, managing the community. So in example, being able to set social tariff recipients or so, or being able to set the coefficient, the community coefficient that was referred to previously by Quentin, but also manage the participants directly through obviously adding, moving, and so on, removing. But also part of this would be to be able to support members as directly as they wanted. So to be able to implement certain settings and changes for members through communication with them rather than them having to do it themselves. They were also interested in being able to use the UI to optimize the community. So identifying surplus, opportunity or deficit patterns, and simulating scenarios. This was something that was, even though we do have a digital twin use in the project, this was went beyond the scope of the UI to actually provide this as a tool for the community managers. So this is not something that we were able to implement. And with this, I will pass on to my colleague Markus, who will now show you the designs that emerged based on these insights.
Mal anscheren, sonst kann ich ja schon anscheren. Yes, thank you, Lisa. Just have to switch over to my computer. So I hope you can see my slides. I'm just going into full screen mode.
Yes, indeed. Thank you very much, Markus.
So thank you all. My name is Markus Garschal. I'm also part of the AIT team for the Intelligent project. And what I'd like to do now is to give you an overview on how we translated the requirements and expectations of community members and managers into a concrete interface design concept. So how did we approach this? We followed an iterative design and development approach that started with the creation of an initial design concept for the community manager and the community member interfaces. In a second step, we then conducted 2 co-creation workshops, in this case with Irish community members and also community managers from all the involved pilot sites. In addition, we conducted a feasibility workshop with the responsible technological partners. This was, for example, important in order to make sure that the data that is shown in the interfaces is also available in the backend. And feedback from all these workshops allowed us then to revise the initial design concept, and then on the basis of our final design concept, we could then conduct 3 evaluation studies that again involve both groups, the community members and the managers. And I'd like to now directly go into an overview on the developed design concept. First, the community member user interface design concept. What you can see here on the right side is the landing page of the community member user interface. So since community members indicated a clear preference for mobile use, we developed this interface with a clear mobile-first focus. The goal for this landing page was to display the most important information at a glance. So what is displayed on this first screen is on the one hand an overview on the so-called energy flow, so a comparison of your current energy consumption and production. As you can see here in the smaller screenshot, we also played around, experimented with alternative visualizations of this energy flow. However, for example, this one here, this sun-like visualization of the energy flow, it was then considered a bit too hard to understand for users, so we decided not to include it to the final design concept. Yes, in addition to the energy flow, right at this first page, you're also presented with the most important facts on the most important facts on the effects of the P2P trading and your own related benefits. So that's what you can see here at the right top of the screen. For example, the degree of self-sufficiency that your household achieved yesterday. And as a general design principle for this community member interface, we try to fulfill the need that Lisa just mentioned, that we have users with different levels of interest, different levels of literacy, So this is, for example, why this landing page also includes the smart summary on the bottom that gives you an overview on the most important facts without having to read the chart. Let's go to the next element of our design concept for the community members. So what we did is, in order to, in particular, support this more infrequent use of our system, we included a so-called mini dashboard. So instead of a simple menu that would require users to browse the different subsections of the app, users are presented with the most important information as soon as they open the app of the menu, the menu of the app. So, for example, at a glance, you see the current community price of energy. Only if a user then wants to explore the price development in more detail, he or she would then have to go into the respective subsection of the app. And in general, our community member interface follows a flat information structure in order to ensure the best possible understandability, the most easy navigation. Yeah, let's now have a look to two other subsections of the app. What you can see here on the left screen is a detailed view of your energy flow. So, for example, here you get a breakdown of the destinations of the energy that is produced in your household. And together with that, a comparison with the consumption. So that would be the red line here on the chart on the left screen. What is important here is that at the top of the screen, you have the option to switch between the data of your own household and the data of the whole energy community. This is important because it provides transparency, allows users to understand their contribution to the energy community, and thus also enables to foster a sense of community identity. The other screen that you can see here on the right side provides users with an overview of the development of the grid and the community energy prices, and also allows to compare these prices. And again, also makes the benefit of the P2P and trading visible. And here maybe one final screen of the community member interface. This is the screen that allows you to configure the P2P trading according to your individual goals. So, for example, as we heard, financial benefits, self-sufficiency, sustainability, these different motivations to participate in such a community. But yeah, here, for example, you also have the option to select a preferred trading partner to enable this inclusivity aspect that we've seen is important in certain sites. What is also important here is that for all these options, you are provided with a description of what this specific optimization mode means. So the goal of the screen is not only to reflect the different motivations of users, but also to communicate the automated system behavior in a best understandable way, and thus also to support the development of energy literacy. That was the first interface, the one for the community members. And now I'd like to give you a quick insight in the community manager user interface concept. As you can see here on this first screen, for this interface, we prioritize the desktop view, since this is the way that most community managers will use the interface for their monitoring and management tasks. As for the community member interface, also the community manager interface provides users with the most important information at a glance. On the one hand, an overview of all management relevant KPIs, and on the other hand, an overview on the current community production and consumption, as well as core trading, billing, and system status information. All that on the landing page. However, in order to support personalization, the KPIs displayed here on this screen can be configured via the settings. Yeah, and maybe also to mention on the top of the screen, you can see that also alerts, such as, for example, that an asset is currently offline or so, are directly provided here on the landing page, since this is really core information. Yeah, here on the second screen, you can see an overview of the actual trading activity. So what you see here on the left side is a visualization of the forecasted and actual trade volume in your overall community. Below that, an overview on the trading-related KPIs that community managers need for the performance evaluation. And in addition, the main table on the screen gives an overview of the trades per member. So how much energy was sold and bought by individual households and other related indicators. Yes, of course, the community manager interface also provides all necessary functions for the member management. On the one hand, an overview on all existing community members, including all important information, and also an overview on the status of their assets. So, for example, if a specific asset is controlled by the P2P trading mechanism or not, and also maybe if there's currently an asset that is offline, then it would be indicated red. Yeah, in this screen, you also have the option, of course, to add or remove community members. And what is also very important here is that community managers also get the option to edit the data of individual members, especially for those who don't feel comfortable to do certain things on their own, to manage their assets on their own, to add their billing data on their own. So community managers then have the option to do that for the members. Yeah, and here, last screen of the community manager UI. This screen provides an overview of all the data related to a specific community member. This is, on the one hand, all the member-specific indicators. So basically, the data that the community members also see in their interface. And in addition, here you get, as a manager, also other member-specific data, such as the information about the reliability of the consumption and production forecast, the billing status, the trades for this specific member, all these things. Yeah, and by that, I think we are anyways already a bit behind our schedule. So let me conclude with some general recommendations. On the one hand, what we learned is that our user interfaces have to support the understanding of the energy system as a set of relationships, have to allow to prioritize the indicators to reflect the different user motivations, enable both quick insight, but also deeper exploration. It's important to communicate the automated system behavior in a very understandable way, especially for the members, and to empower these users with control settings. It's important to also design for infrequent use. And on a more holistic level, the user interface has to be adaptable to the different regulatory and technical contexts. And of course, as we heard already in the requirements presentation by Lisa, good onboarding procedures and continuous engagement of participants are also key to the success of P2P energy trading among the members of an energy community. Yeah, thank you very much. And I think
we're at the end. I don't know how you want to say this.
No, thank you very much for the presentation. There is a lot of insightful data, and especially for the second and the third presentation, I think that it is very important to share results and to share what the project achieved so far. So I'm not sure that we have enough time for the Q&A session, maybe to leave it for the next webinar, for the next time. I would like to call Laura, maybe for the closing remarks of the webinar, or maybe if some of our participants have some question that would like to ask our presenters. Just to move maybe 1 or 2 minutes for that. No questions in the chat? Okay. So Laura, would you be so kind maybe to outline this presentation and to say something for the closing remarks of the webinar?
Thank you, Jasna. Regarding the questions, we went a little bit over time, but feel free to reach out to us through our channels. Also, some of the speakers have left their contact details in case you want to follow up, but do not hesitate. So since we are a little bit over time, I'll keep it short. I want to thank our speakers, Paulo, Quentin, Lisa, and Marcus for sharing all these insights from our project. Also thank all the participants for joining us today. I believe this webinar has highlighted one of the key principles behind Intelligent, which is like the successful innovation starts by understanding the needs of the people and the communities who will use it. But this is, of course, complementing the very necessary assessment of the technical and functional requirements, the regulatory context, and also all the operational aspects and data availability. So this completion of all this work represents an important achievement for the project, and through all these stakeholder engagement, user research, participatory design activities, together with all the technical and regulatory analysis that have been performed, we have created a strong foundation for the development of our solutions. All these results presented today will feed into the next phase of the Intelligent project, where we will move beyond these requirements and concepts towards technological development, which has already been ongoing since the beginning of the project, of course. But all this feedback will feed into the integration and the real-world validation in the second part of the project. In the coming months, the coming year, we will continue working on the different building blocks of our Intelligent ecosystem, creating an open source and interoperable platform, developing the flexibility and optimization services, and of course, testing these solutions within our pilot communities in Switzerland, Portugal, and Ireland that Paulo shared at the beginning of his presentation. So our objective is not only to demonstrate the technological solution, but to show how all these digital tools can empower the citizens, support energy communities, and create new opportunities for the energy value chain, while of course helping the grid operators, the DSOs, to manage the increasing complexity of the distributed energy resources that are increasing across Europe. So this webinar was the first step to sharing the results with our wider community, but we look forward to continuing this conversation in future sessions, where we will present, of course, the outcomes of our technical development and demonstration activities. So please keep an eye on our channels, on our website, to keep track of the developments. Thank you again for your time, and I give it back to Jasna to give you any final details. Thank you.
Thank you, Laura. A big thanks to our presenters. Of course, we look forward to seeing you in the next phase of the Intelligent project. This concludes our session. For our participants and attendees, stay tuned for updates on social media. Do not hesitate to reach us out anytime, as Laura mentioned before. Thank you all, and have the the rest of the day. See you soon.
Thank you. Have a